Thank you, Roma, and also from my side, welcome everybody, and thank you for joining the webinar. So, to give you an overview of what I want to show today, first of all, I'd like to introduce the 3D Experience platform and also touch quickly on the subject of artificial intelligence. Then I'd like to talk about resources and how we manage them in DELMIA machining. After that, I'll go into the specifics of the CAM workflow. And then to finish, I'd like to take a closer look at mold and die machining and mill turn. So let's start. So the 3D Experience platform is a common database within a company. And the idea behind that is that all the functions in the company from design to manufacture will work on the same data. And the reason for that is that we believe this improves collaboration between the different functions and also makes the processes in our business more efficient. So if we apply that to CAM programming, it means that on the same database on which the designers bring their latest 3D data, we also store our tools or CAM programs and everything else that we need for programming. And the idea of that is that everybody is always aware of what's going on, especially if changes happen. And speaking of changes, one big change in the industry right now is the topic of artificial intelligence. And of course, the SO is also looking for ways to incorporate this technology into our products. And in DELMIA machining, with the current release, we have a function that's called predictive operation, which is based on AI technology. And the idea behind that is to have something like a GPS for less experienced users to guide them to the optimal machining solution. So to demonstrate this, I have a video here. So in the beginning, we're using, I call it traditional feature recognition and process templates to machine those pockets. But what we can see, the one in the middle with a little bit odd shape is not being recognized, ergo there is no toolpath generated. So what we can do now with predictive operation, we can click on that surface and it gives us some proposal on how to machine it. And we can select then the appropriate template for that based on that proposal. And the same we can also do for that radius surface. And as well for the bigger bore in the middle. So with that done, we can calculate the toolpaths and start our machining simulation. And as we can see, the parts being machined and the area that's not been covered by feature recognition can then be done with the help of the proposals by the AI. So with that said, I'd like to move on to resource management. And of course, when we're talking about resources in CAM programming, we have two topics to take care of. First, our machine and the clamping, and also the tools. So, and for the tools, we have quite good solution to really reduce the workload on the programmers for that topic. So what we can do is directly from the 3D experience. So from within the software, we can access the vendor websites, the tool catalogs to download the tool models from there and use them to build our tool assembly. So I have a quick video to demonstrate that. So this is an example from the ISCA catalog. So we can filter for tool diameter, pick the appropriate tool, download the model. Then from there, we can also then search for the inserts that will fit that tool in our application. then download that as well. And lastly, what we need is a holder that will fit the tool and the machine we're about to use. So, and once we have all those components, we can start to assemble them. So we just pick the tool holder, the inserts, and the tool body, and it's being assembled for us. So this is really a huge time saving, no manual inputs, and we have our tool there ready for simulation and with an accurate representation. So the next topic that I mentioned was accessories or fixtures and machines. And within 3D Experience, we also have the capability to define kinematics for those so that they function like the real-world objects. So this is why we talk also about digital twins. And in this video, I just want to demonstrate what that capability allows us to do. So it allows us to really set up our clamping and machines in a modular way so that they function like real-world objects. So here I'm now setting up a second vise on that machine. So first I'm gonna load in the base of my vise. So like in reality, I have the base onto which I can mount different jaws. And that's what I'm gonna do now. Once I've placed the vise, I'm gonna load in my jaw. And yeah, like in reality, there's two possibilities to mount that jaw. And I can decide which I take and then mount the jaw accordingly. So once I've mounted the first one, I'll mount the second, and I can control the vise or the kinematics of the vise via what we call machine instructions. So here I can then set how far I want to open or close that vise, and of course I can then yeah, put the part onto that vise or make a copy. And in this example, I also just want to demonstrate one more time the modularity, how we can handle fixtures. So here it's a more traditional setup with clamps. So they can all be moved individually and mounted individually on the pallet. And so in this way, we are really able to give you yeah, a realistic representation of the tools and fixtures you're using. Then I already touched on this briefly in the introduction. So in 3D Experience, we're working on a database, which means every object in the database is unique, and those objects are also linked. So for example, if I now have a tool that I have to change or a fixture that I have to change, I can quickly look at the relations of this object. And this then tells me where else or in which programs is this object being used. So in this example, I have this tool. I click on my relations function, and what it brings me up is an overview of the programs in which this tool is being used. So this is something this capability you will not get with any file-based CAM system because the files are individual, but on the database everything is connected, and you can analyze the connections to give you some insights that you would not get otherwise. So then I think it's time to have a closer look at the CAM workflow, starting with the CID data. So in 3D Experience, of course, we have a CAD system integrated. It's called CATIA, but 3D DELMIA machining on the 3D Experience platform is not limited to that CAD data from CATIA. We can also connect to different CAD system via interface, so that we can work on that data as if it were a native data. So for example, we can connect to CATIA V5, SolidWorks, but also third-party systems like NX, Inventor, and others. And yeah, I just want to quickly demonstrate how that works based on CATIA V5. So I have here a model in CATIA v5. I then connect to the 3D Experience platform. And once I'm connected, I can store that model or that data directly into the 3D Experience platform. And it's then available in the 3D Experience platform as if it were a native 3D Experience file or model. So if I open that up, we can see here the whole tree or history of how that part has been designed. And what's also worth noting here is that this file is still owned by the CAD system from which it's coming from. So that means in 3D Experience, I can work with the data, but I cannot modify it. So that means having that data available as if it were native data gives us a great advantage. So when design changes are coming, my CAM program can be updated to that change, and I don't have to make a new program just because something in the design was changed. And how that works, I would like to demonstrate here. So first we are again back in CATIA v5. We're making a change to that pocket to make it a little bit larger. We're then saving that change into the 3D Experience platform. And here I already have my finished CAM program. What I then do is I update that process, and I can now see, okay, I have the bigger pocket here. So it's now 35 as per the change before. I switch back to my application app. I can see here the toolpath that's been created for the smaller pocket. We can see, okay, yeah, it's not fitting the current situation. So I delete the toolpath, recalculate. And what we can see here then is that now it's been updated to the current situation. So this is, of course, a huge gain in efficiency that we can have by using that interface. So that when design changes happen, we don't have to reprogram the whole part. We can just update it. So now with the CAD data covered, we can look at how to prepare a manufacturing cell, as we call it. So first of all, this is one of the big topics of the 3D Experience platform is to how to collaborate. And here we have application that's helping programmers to know what they have to do. So for example, here we have it's called collaborative tasks. For example, my manager could create a task and assign it to a team of programmers, and then each of those programmers could pick those tasks. Everybody knows then who's doing what, and from this task we can attach the part that's to be machined. And this way everybody knows who's doing what. They know on which data they should work. And this is just one of the ways the 3D Experience platform is helping to improve collaboration or make collaboration more easy. So once we know what we got to do, we can start doing it. And to make this more easy, we have a capability that's called engineering templates that allows us to predefine a manufacturing scenario so that it becomes so that we can avoid repetitive tasks like selecting machines, selecting tools, setting up a fixture. And this I'd like to demonstrate quickly in 3D Experience. So I have here my part from before. And what I'm going to do now is I'm going to open up one of my libraries where I have my setup template stored. I have this one here. I hit template instantiation. So this is going to take a little while to load because in the background we're loading the machine, we're loading the tools that come with that machine. So we can define a standard set of tools that we typically use on a machine. and we are also loading the fixture. And then what happens in that setup template, we have a dummy workpiece, which is just an empty part. And it's going to ask us to specify the part that we're going to machine. And so this is this dialog here. And once we've specified that, it's going to replace that empty dummy part with the actual part to machine. So I click here. So now I've got the part I want to machine specified. I hit OK. And it brings up a preview of my manufacturing cell. So I got the machine here, I got the workpiece, the stock material, and my clumping here. And what I can do now is by help of parameters, I can then adjust the dimensions of my stock workpiece or stock material. I can change my clamping configuration. So right here, I have 3 vices now, but let's say I just need the one in the middle. It's then gonna update to give me a preview of what I've configured. So, and I also can change the orientation of my jaws. And lastly, I can give a name to my new created work cell, and I confirm. So it's now creating that manufacturing cell in the way I configured it. So I just have to quickly update the workpiece position. So it's mounted on that vise. So now it's all there. And yeah, now I just have, what I have to do now is I have to specify the one time the workpiece in here. And I have also already some pre-configured machining operation in there. So I just have to select the facing operation. So I just have to select the face I want to machine, and then I can calculate the toolpath. So this is one way of how we can quickly and easily configure a manufacturing cell, so without having to do too much manual labor, and especially no repetitive labor. So once we've prepared our manufacturing cell, there's one more functionality that we can use in order to avoid problems or issues doing programming, and that's a reachability check. So with the machine also included during the programming, then we can check if if the part fits, if the tools are long enough, if the travel limits of the machine are sufficient to reach all those positions, which is the case here. And yeah, this is just one useful feature to make sure that our project will work as we intend to, and yeah, save us some headaches that could occur. So now with the preparation done, it's time to start programming. And there's one topic here I want to highlight is feature recognition and process templates. So in 3D Experience, we also have the technology or the capability to define user-defined features and assign templates to them. So once that feature then has been recognized in our part, we can apply the operations that have been defined in our process template to that feature. And this works for prismatic features or also boring features in the same way. And so once we have all the operations defined, especially for the drilling operations. There's possibility to sequence them so that, for example, the spot drilling operations that are all done with the same tool are done one after another to minimize the number of tool changes. So in order to have an optimized program, and yeah, once that's done, all that's remaining is to compute the toolpaths, and then it's all that's left to do is to cover those areas that have not been covered by the feature recognition or the process templates. Then when we talk about programming, or when the programming is finished, after that, the next step would be to simulate that program. So in 3D Experience, like in any CAM system, there's many ways you could simulate. It could just be by displaying or replaying the toolpath. Of course, there's also the capability to do a material removal simulation. To detect collisions, to optimize the program. And of course, there's also the capability of full machine simulation. And that machine simulation can either be done based on the internal apt source file, or it could be also done with the help of a controller emulator provided by one of our partners. It could be done based on the ISO code directly within 3D Experience. So when it comes to verification, you have two options. You could either use directly, or could either do it directly in 3D Experience, or use some third-party system to do the verification. Both possibilities are there, and both possibilities are supported. So then when it comes to output, as I previously mentioned, the internal source file is APT. It's been with CATIA v5, so CATIA v5 users will be familiar with that. And since that is the case, the post processors that you had in v5 can also be used in 3D Experience, with the only caveat being that there might be some modifications to be done to use the latest features of 3D Experience. But in general, or in large, the post processors will still, from v5, will still work. So now I want to focus a little more on mold and die machining. First of all, what we want to do in mold or die is, of course, there's a lot of very intricate, detailed features in mold and die. So we want to really focus our toolpaths to those areas, or limit our toolpaths to those areas in which we have remaining material. And for this, we can define rework areas. So here I just want to give a quick example of how we calculate those rework areas. So we define the tool that's been used previously. We can then divide those rework areas into vertical and horizontal areas. And we can create subsets of the rework areas. So example, to use different type of operations in different areas, or to use or to leave out certain areas. And once we've defined an operation, we can here, of course, then also define the 5-axis collision avoidance, so that we can also, with very small tools, with very short reach, we can calculate or compute a collision-free toolpath. And yeah, Dassault is also constantly developing our toolpath technology. And one of the more recent additions to that is also the support for barrel cutters, which are a topic in certain mold and die applications, just to reduce machining times, or especially time in finishing, and thus improving the profitability of the machine shops. Another interesting addition in the current release is the multi-axis roughing capability. So what we have here is a toolpath that stays free axis all the way, in all the areas where it's possible, but for example, it detects undercut areas, and in those areas we are using 5-axis motions to get in there. And of course, the toolpath type that we see here is adaptive concentric. So with that, we really can maximize material removal and at the same time increase process reliability. And all this is done in 3-axis as well as in 5-axis where needed to machine undercut areas or difficult to reach areas. So moving on to mill turn. So when we are talking about mill turn, we are also often talking about rather complex machines and the need to represent them accurately so that we can give the users the confidence to program them. And this is fully supported in 3D experience. So machines with several spindles, machines with 2 axes moving in relation to each other to create a movement, or complex machines like Swiss machines are all supported in 3D experience and can be programmed. Another topic in mill turn machining is, of course, synchronization of the different channels. So for this, we have a synchronization manager in 3D experience, which lets us synchronize different operations from different channels to each other. So what we have in this view is we have both of the channels. We can see the operations, and then we can define which operation comes after. We can define the order of the operations. And once that's done, we can update it accordingly and run the simulation in the order that we defined. So in this example, we see here first the lower turret machining, then we have the milling, and that's how the part is done. So another topic is when we have a main spindle and a counter spindle, is how do we manage a part transfer. And for this, we have the part sequencing function, which highlights the workpiece visually. The colors can be defined, and also highlights okay, which is the part holding the workpiece right now, so that we have an easy overview of where the part is attached and at the current simulation that we are doing. So what we then can do is we can bring in the counter spindle to the part by just clicking on the surfaces, and we define it as a machine instruction. This movement we can then define also the opening and closing movements of the jaws. What we then do is we define the part now attached to the counter spindle. Once the counter spindle is moved in, so then this is graphically highlighted here by the change of the color, and then we detach the part from the main spindle before we move to the new position with the counter spindle. So, and once it's moved over, we then define this new position as a new setup. So, and this is how it looks like in the simulation. Without the spindles rotating, but the same can also be done in phase. So with the spindles rotating, and for that we have the possibility to change the instructions here, set a rotation speed. So, and when you simulate it, it looks like this. And I've already talked about this previously before. The capability to define process templates and user-defined features. So the same cannot only be done for milling, but also for turning applications. So what I do here is I have a program that I've done that I'm happy with. I can define now the surfaces as a user-defined feature. I select the activities I want to be associated to that feature. And what the system creates for me now is something called a know-how cell, where we have that geometry and those operations associated to it. What we can do is create measurements on that geometry to define in which ranges we want to recognize that feature. And also those measurements could be used to drive tool selection or tool queries. And once that know-how cell is defined, we can then apply this to different parts, so that we don't have to reprogram proven processes over and over again. So, and with this, we are, I think, more or less on time. So I'd like to thank you for your attention. I'd like to thank you for joining this webinar. And as promised earlier before, we now have the possibility to hear some of your questions, and I'll be happy to answer them where I can. Thanks a lot.
You have the Q&A tab if you want to ask a question.
Yes. So there's one question about do we have the KUKA catalog available? So this is something I didn't mention before, but not only can we program, let's say, conventional machine tools like lathes, mill turns, milling machines. We also can use robots. We also can program robots for milling applications, for example. And yes, in 3D Experience, we have a catalog of all the major robot manufacturers available. So there's an extensive library actually from KUKA, FANUC, and others. So yeah, this capability is there. Let me see, what else do we have? So there's one more question regarding AI. So the question is if the program can be checked by AI or optimized. At the current stage, no. The function that we have right now is just a proposal for, let's say, new programmers in 3D experience or less experienced programmers. But of course, this topic will further evolve. There's R&D is working on it to bring more capability. But what we have today is a start, but it's not the end of the journey. So there's also a question in the future, can we modify 3D model in DELMIA? So DELMIA is geared really towards manufacturing. So all the design modification or working with CAD data is done in CATIA, but so we have the situation that a lot of people are probably familiar with CATIA V5, which has been a CAD/CAM system, file-based CAD/CAM system, which has both the CAD part and the CAM part included in it. And this has now been moved to the 3D Experience platform, meaning that on the 3D Experience platform, we have applications for CAM programming, like I've shown in this webinar today, but we also have applications for CAD design. So yeah, on the 3D Experience platform, we can modify design data or modify 3D models as well as do the CAM programming for it. Um, so there's also one question about okay, okay, so there seems to be some confusion about the cat. Um, no, so there's one question about the cut. If we need external cut, so no, you can use, of course, the cut system on 3D Experience. But if a customer happens to have a cut system already in place, this can be via the interface. We can connect to that existing cut system and work with it as if it were native data. There's one question about the tool import. So after tool import, can we automate required feeds and speeds as well? So as of today, no. So you have still to set your feeds and speeds for those tools. But yeah, you have a nice capability where you can define feeds and speeds on assembly level. You could define feeds and speeds based on the material you're machining, based on the application that you're doing. So, for example, roughing or finishing. So there's a lot of capability to manage feeds and speeds, but there's no automatic transfer of feeds and speeds from, let's say, from a manufacturing catalog or manufacturing recommendation. This is, as of today, manual still. Um, so there's one question about, again, about the creation of cutting tools. Is it possible to define also processing presetting data to eventually interface with presetting machine. So when we are generating our NC output, we also have the capability to generate a setup sheet. So we get the information of about the tool lengths of all those tools that we're using in our program. So of course this data could be used as input for presetting, or yeah. Okay.
Okay, Robert, we're done. Okay. So thank you everyone for joining. As I was saying at the beginning of the session, the recording and the presentation will be available on the fabrication community. We will send you an email when it's available. This community is also a place to ask your questions to our experts, so don't hesitate to start the discussion there. Thank you all for your time. Thank you all for joining, and I wish you a nice end of the day. Thank you, Robert.
Thank you. Bye.